Let's take a look at an example of how to find the 40th term in an arithmetic sequence. The given arithmetic sequence here is the one that starts with 100 and goes to 97, to 94, to 91 as its next few terms. Remember that an arithmetic sequence is one where there is a constant difference between terms, which means that we are either adding or subtracting the same thing to each term to find the next. In this case, it's pretty easy to find that to go from the first term to the next term, we're simply adding -3, or you could say subtracting 3. That means that there is a constant difference between each term. There's a constant change. Remember, whenever we have a constant change situation, we can represent this with a linear equation. So we can use a linear equation to represent this. So the first thing that we should do is find an explicit formula. We could use this pattern and simply subtract 3 a whole bunch of times until we find the 40th term, but that's going to take a long time, and ultimately if we wanted to find the 100th term or the 1000th term, that would be a lot of work to do. So it's good to be able to find an explicit formula to generate terms that are well into a sequence. So again, since this is arithmetic, we can use a linear equation to find this. So we're going to use y equals mx plus b. But so that it models the situation better, we want to change the y and the x. Remember that with arithmetic sequences, we don't plug in x's. We count the terms. It's going to be like an n for the input. And the output term would be something like a sub n. So the inputs are actually the term numbers themselves. And here we were given the first 4 terms. And the outputs, the first 4 terms are 100, 97, 94, and 91. So instead of writing here an mx plus b, y equals mx plus b, the output is not a y, it's an a sub n. So let's use a sub n equals, we're still looking for the rate of change. The input is an n instead of an x, and we're still looking for b. So we need to find m, and we need to find b. Remember that m is the rate of change, and you can either use the slope formula, use 2 points to substitute into the slope formula in order to find the rate of change, or if you know that conceptually m is the rate of change, we can see that there's a change of 3 between each of these terms, but this is not an increase of 3, this is a decrease of 3. So since this is a constant decrease situation, the slope is -3. We're going down 3 each time. So you could write here rate of change is -3. This is how we found this. Now b again loses its real-life value or real-life meaning in sequences because sequences begin with a first term and the initial condition relies on finding the output value when the input value is 0. So to find b, we're going to have to use our algebraic method. And I guess we're not using y and x's here, we're using a sub n equals m times n plus b. So we're using this equation, and we're simply going to select a point to work with here. And I'm going to go ahead and select this first point because 1s are easy to work with and 100s are easy to work with. It doesn't matter which point you use, it'll work out the same each time. It only makes a difference in how easy or difficult the math to get there is. So I'm going to substitute in my values. A sub n is 100 equals, I'm going to substitute in my slope, which is -3. Substitute in my n, which is 1. My unknown is b. So when I solve this equation, I should find out what b equals. Simplify here, -3 times 1 is -3. And to solve for b, I simply add 3 to both expressions. This will leave me with, in the left-hand expression, 100 plus 3, which is 103. And in the right-hand expression, just b. So I find that b equals 103. So I have found both m and b that I can substitute into my explicit formula equation. So I can use that information to write my formula, my explicit formula, a sub n equals m is negative 3 times n plus b is 103. This allows me to find the 40th term, and when I'm looking for the 40th term, what that means is I'm substituting in 40 for n, and I'm looking for a sub n. So I'll go ahead and substitute in 40 for n into this expression over here. So this will be a sub 40 equals negative 3, substitute in 40 for n, plus 103. Simplify that right-hand expression. This is a sub 40 equals negative 3 times 40 is negative 120. Simplify further. It'll be a sub 40 equals negative 120 plus 103 is negative 17. So I find that the 40th term is negative 17. And that is what the question was asking for. They wanted to know what the 40th term of the sequence was. The easiest way to do this is to first find that explicit formula. Once you've found an explicit formula using the strategies that we've talked about before for finding an equation of a line, you can substitute in the term number that you want for n. We wanted the 40th term. Substitute it in for n, and simplify the right-hand expression. That will give you the output value, or the 40th term, which is negative 17.